Good morning, my dear students. I am Karpanasamy, working as an assistant professor in KSR College of Engineering. So today we are going to discuss about the CMOS inverter. So before going into this, we should know transistor act as a switches, right? So based on this, we are going to see how the CMOS inverter characteristics works, right? We are going to see the voltage transfer characteristics of the CMOS. So based on this transistor act as a switch concept, we are going to discuss how that CMOS inverter works, right? These MOS transistors are actually electrically controlled switches, right? So here we are going to use this NMOS and PMOS to construct the CMOS transistors. This NMOS transistor consists of three terminals, the gate, source and drain. Similar to that, this PMOS transistor also contains a gate, source and drain, right? So when this gate input is equal to 0, then the transistor will be act as an open switch in the case of NMOS transistor. When the gate input is equal to 1, then this transistor will act as a closed switch, that is in on condition. Similar to this, in PMOS transistor, when gate equal to 0, the transistor is in on condition, that is the switch will be in closed condition. When the gate is equal to 1, the switch is in off condition or in open condition, right? So this is that is this PMOS and NMOS are opposite to each other, right? So the voltage at this gate controls the path from source to drain. So there is that's why it's called as a switch, right? The gate controls the path from source to drain, the current flow in between the source and drain. So now we will see what is CMOS inverter. So the inverter is similar to that of our NOT gate, so which consists of the combination of PMOS transistor and NMOS transistor, right? So this is the actual construction of the CMOS inverter. So it is similar to that of our NAND gate, NOT gate. So NOT gate, what is the output it will provide, right? So if you are giving 0 as input, it will provide 1. If you are giving 1 as input, it will provide 0. So this is the thing we are going to discuss here. So here we are having two transistors, one PMOS and one NMOS. These two are connected with the same input, right? And produces the output Y. When you are applying 1 as input, so 1 to this input, the PMOS transistor will be in off condition and NMOS transistor will be in on condition. So what will be the output which will produced by this CMOS inverter is when this transistor is in off condition, that is when this PMOS transistor is in off condition, it provides, that is it is in open state, right? So there is no supply will be flowed through this. So when it is connected with the NMOS transistor, that is when the NMOS transistor is in on condition, it is connected with the ground. So it pulls down to 0, right? Pulls down to 0. The output across this terminal will be equal to 0. Okay, so this is the thing, this is the net output will be received. So when you are applying 1 as input to this inverter, it produces 0. So this is the first condition, right? Then the second condition is when you are applying 0 as input to this transistor, 0 as input to this A transistor, A, then this PMOS transistor will be in on condition and NMOS transistor will be in off condition. How this PMOS transistor will be in on condition? When you are applying 0 to this PMOS transistor, this will be in closed condition, right? That is in on condition. So when this transistor is in closed, act as a closed switch, the supply will be flowed through this, right? Pull up to 1. That this Y will be pulled up to 1 because it is connected with VDD. When this switch is in closed condition, then VDD will be flowed through this. So it produces the output as 1. So when you are applying 0 as input, it produces the output as 1, right? So this is how the CMOS inverter works. Okay, so this is the condition of working of CMOS, right? When you are applying 1 as input, it produces 0 as output, right? When you are applying 0 as input, it produces 1 as output. So depends upon the applying input, these transistor will be produces the off and on conditions, right? So based on that, the output will be produced. And another thing you might know is why do we go for the CMOS inverter and what are the advantages of going for the CMOS inverter rather than using a single transistor, either PMOS or NMOS transistor, right? So we are using MOSFETs as NMOS and PMOS, and what are the difference between that individual transistor is used? Other than that, why do we go for the CMOS? Okay, you should understand why. When you are going for the combination of both PMOS and NMOS transistors, this PMOS transistors provides strong one, right? Then this NMOS transistor will provide the strong 0, right? So that's why we are going for this. Both strong 1 and strong 0 will be provided because of the combination of this PMOS and NMOS in the CMOS characteristics, right? So then here we have a CMOS NAND gate, 3 input NAND gate, 2 input NAND gate CMOS. So here the combination of two transistors, two PMOS transistors and two NMOS transistors are used here. Okay, two PMOS and two NMOS transistors are used here, and here the two PMOS transistors are connected in series parallel and two NMOS transistors are connected in series. Okay, now by applying input this combination, what will happen we will see. By applying input A and B are 0, both the input A and B are 0, so then what will happen, right? If you are applying 0 as input to this both the transistor, both the PMOS will be in on condition and both the NMOS will be in off condition, right? So you know what is the output of NAND. When you are applying 0, 0 to the NAND gate, it produces 1 as output, right? So by combination of these things, right, when you are applying 0, 0 as input, both the PMOS transistor will be in on condition and both the NMOS transistor will be in off condition, right? So when both the transistors are in on condition, it is connected directly with the VDD, so that directly VDD will be pulled out to this output, right? And these two transistors will be in open condition, and these two transistors will be in closed condition. These two act as a switch, closed switch. So the VDD will be pulled out to this one. Okay, and then for the next combination, you see when you are applying 0 as 0 to A and 1 to B, then it will produce as one transistor will be in off condition and another transistor will be in on condition. That is, one PMOS will be in off, another PMOS will be in on, and here one NMOS will be in off condition, one NMOS will be in on condition. So by seeing this, one will be act as a open switch and one will be act as a closed switch, right? So because of the parallel combination of these things, either one of the transistor will pass the VDD. Okay, so the VDD will be passed to Y. But in the case of this NMOS transistor, here the first NMOS transistor is connected in that is not connected, that is not in the closed condition. So there is no input will be flowed through this. So the net output will be 1, right? By seeing this, you can understand. By the parallel combination of this 1 and 0, this produces this on closed, that is on condition. This PMOS transistor will pass the input to this Y. But here this is in open condition, so there is no connection will be made in between this. See this next input. It is also similar to that of the previous case, right? Both either one of the transistor will be in on condition, so it passes this PMOS transistor. On PMOS transistor will pass the Y. Okay, so this is the condition which will be made to produces the output as 1. So this is the final condition of the 2 MOS input NAND gate. Here both the inputs are 1. So by applying both the input as 1, both the PMOS transistor will be in off condition. So these two will be act as a open switch. So there is no input will be flowed through this, right? And when you are applying both the input as 1 to this NMOS transistor, both the transistors are act as a closed switch here. So it is pulled down to 0. So the output is pulled down to 0. These two are a closed switch. The supply will come here. The connection will be made from here to here. It is act as an open circuit. So there is no flow from VD to output. But here it acts as a closed switch. So what will happen is the output is pulled down to 0. So the output will be equal to 0 now. Right? This is the combination of NAND gates. So this is how the NAND gate, CMOS NAND gate works, right? So based on the connections, we will see how that is based on the connections of this PMOS and MOS transistors. We will see how the output will be produced. Okay, so this is a two input NAND gate. Okay, thank you. We will see the remaining topics in the next class. Thank you.